So now we will look at three assumptions in combination, and all these three relate to the error term epsilon. And the assumptions are R2 says the expected value is R2 says there is this error, R3 is the expected value of the error term is 0, and the error are uncorrelated. Okay, there is no correlation. So since this is a time series, what we are saying is that over time the errors are not correlated with each other. In other words, there is no autocorrelation in the errors. So once again, we can use the same set of plots that we discussed before. So residuals and fitted values. Okay, so that will give you, if that is random, we've already verified that that is random. Okay, or we can plot the residuals over time. So which means it's a line plot, not a scatter plot, but you take the error values and just plot them sequentially. Okay, when you do it sequentially, if there is autocorrelation, then you will see long series of similar values. So if there is, if you 0, okay, some are positive, some are negative, right? If there is long sequence of positive errors or long sequence of negative errors, so that means there is something going on, some patterns, there is autocorrelation there. If it is completely random, bouncing up and down, then there is no autocorrelation. So that is one way of looking at, plotting the residuals over time, that is sequentially, not a scatter plot. Or we can do the autocorrelation function and PACF. We won't do PACF yet, the partial autocorrelation. But if you look at ACF function, and we will look at some patterns in ACF function and then see whether the autocorrelation within the errors is there or not. And we'll also, there are some tests that we can perform, and we will look at those tests in chapter 10. Okay, so these are the we will do two plots. We will plot the residuals over time, and then we will do ACF and then look at those two. And if you have autocorrelation, okay, then if it is a cross-sectional data, that is, it's not a time series data, then usually the cause is because there is some important variable missing in the data set. Or if it is a time series data, then there are some remedial measures we can do. Instead of looking at the y values, we can take the increments or difference in the lags. Okay, differences can be used to mitigate those autocorrelation situations. We'll talk about those in a later chapter. Okay, so here we're going to look at R2, R3, and R4. Let's go to the Excel file now. Okay, so let's look at the plots. We want to plot the standardized residuals. Standardized residuals is you take the residuals and divide by the standard deviation. So it'll all be some positive and negative around within a narrow range. So let's look at the standardized residuals, and we want to do a line plot of that. So, and our regression output generates the standardized residuals, which is here. Okay, so let's go down. Okay, so those are the standardized residuals, and we'll insert a line plot. Okay, so we'll do that one. So let's move it. So this is standardized residuals over time. Okay, and we are looking for random fluctuations, not long series of positives or long series of negatives, which we see that it is not. It's bouncing up and down, up and down. There is no long series of positive or negative values, which is good thing. Okay, there is one more thing we can do, as I said, is the plot of autocorrelation over different lags. So that means you have to find lag of 1, lag of 2, lag of 3, lag of 4, lag of 5, and so on, and plot it. And that can be cumbersome. So what we're going to do is, I have an ACF macro developed for this. Okay, not the RK macro. So here I have a macro to generate the entire ACF plot. And for that, you have to open the macro file. So I'll have it available to you in Blackboard. So it's called ACF and more XLAM file. Open that. Okay, enable macros. Okay, so nothing will happen here because all this does is it adds a tab called MGT3660. Now click that and you will see two commands, ACF and build model, and then close. If you click close, this ribbon will close. If you click ACF, ACF command dialog box will show up. And build model, we'll use that in the next chapter. So click ACF. That opens up autocorrelation function window. So now you want autocorrelation for what? For the residuals. So we can start from there because there is a checkbox for labels. So when you go all the way to the bottom, okay, check that. How many lags you want? Okay. So we want, say, this is monthly, so let's say we want 3 full cycles. Okay, and where do you want to put it? So where do you want to put the output? Okay, let's put the output about over here. Click OK, and you have the autocorrelation function for residuals, and here is the autocorrelation table. So we have the autocorrelation, SERK, and then the lower and the upper limits of the tolerance limits. Okay, and here is the residuals. Each residual is a bar, and the top and the bottom lines that you see are the lower and the upper limits. So if a bar or curve goes beyond the upper and the lower limits, then that is significant. So we have significant autocorrelation lag 1, lag 2, but lag 3, 4 is not significant. Now 5, 6 are significant, and similarly 11, 12 are significant, and again you see. So you can see that every 6 months, 6 months lag, 6 months lag, 6 months lag, looks like the autocorrelation peaks. So here, since we have monthly data, and this may be significant because in a monthly data, every 6 periods, if the autocorrelation becomes significant, so that means there is maybe some seasonality remaining in the residuals. So that means the model is probably, the errors are autocorrelated serially over time. So we have to take that into consideration. So with this, we can conclude that there is some autocorrelation. So with this, we can conclude that there is seasonal, because every 6 months there is a peak and the data is monthly. So these two should, so if there is every 6 months peaking in a quarterly data, that may not mean much, or in a daily data or something. Since there is monthly and then there is 612, 612 peaking of autocorrelation, there may be some seasonality present in the residuals, and that is a cause for concern, because that means there is a pattern, autocorrelation pattern in the residuals. So the standardized residual plot seems free of patterns. So this one seems free, but however ACF shows significant autocorrelation at lags of 6 and 12 for a monthly series. So this indicates a significant seasonal variation. So we have to be concerned about that.